Okay, we're finishing off problem 1, section 4.4. We just have 2 more parts left to do. So this one is a product, so we're going to have to use the product rule on this. So derivative dy dx. So we'll take the derivative of the first function. That requires the chain rule. So we say 2x squared plus 1, lower the power to the first power, multiply by the derivative of what's in there, that's 2x, and then multiply that by the second function, and then plus the first function times the derivative of the second. Well, that requires the chain rule again with exponential functions. So since it's e to the x, we just copy it, and then we multiply it by the derivative of what's up there in the exponent. So we can simplify this a little bit. We'll get we'll combine the 2 and the 2 here. We get 4. We'll put the x and the e to the 2x in front. So we get 4x e to the 2x x squared plus 1. And then here we'll put that 2 in front as well, and the e to the x, e to the 2x. So 2e to the 2x x squared plus 1 squared. If you wanted to, you could also factor out an e to the 2x and also 2 and an x squared plus 1. You can factor all those out. Not necessary though. So for f then, we've got another one of these ones that has a constant in the numerator, some exponential function in the denominator. So in fact, I'm just going to go ahead and write that how I suggest that we do this type of derivative. We first, if it's just a constant, we can move that thing that's in the denominator to the numerator, minus 0.9x. And then since I've moved it to the numerator, I'm going to call it a -1 power. Okay, so this one just requires the chain rule, and then the inner function will require that derivative of an exponential. So f prime of x here, we'll use the chain rule, general power rule, move that -1 to the front, so we get minus 20. This inner function stays just as it is. Then we lower the power by 1. Then we multiply by the derivative of what's on the inside. The derivative of 3 is 0. For the derivative of the rest of this, again, the first thing you want to do is just copy it. So we get e to the power of negative 0.9x. And then we have to multiply that by the derivative of what's up there, which is going to be negative 0.9. Okay, then we can combine our constants here. 0.9 times, let's see if we can do this. That's 0.9 times 8 times 20. I'm not sure exactly what that's going to be. I'm just going to grab my calculator real quick. We can do that one. So 0.9, I'm just going to multiply the constants together. 0.9 times 8 times 20. So that's 144. So we're going to get 3 negatives multiplied together. A negative, a negative, a negative. 3 negatives multiplied together gives us a negative. So we're going to get negative 144. I'll put that e to the negative 0.9 x, and then I'll just, in fact, actually for that one, let's go ahead and move that to the denominator because it's got a negative exponent. Let me fix that. So we'll put this over that term right there. So that's 3 minus 8 e to the negative 0.9x. It was a negative power. I moved it to the denominator. Now it's a positive power. So that's a good final answer for this one here.